How many people had a chance to listen to David Hayes' video? If you haven't, you're going to want to do that. But recognize that I'm giving you a counterpoint to that. What he's expressed is what everybody else in the industry is expressing. You form your own judgment, but hear me out, okay? I guess that's what I'm saying. Kansas City DEMA chapter asked me to come last fall, and I gave a presentation on this. So this is kind of a revision and an update. It's the question of conceptual versus logical versus physical data models, and I want to argue around that and then move into, I think, the better way of thinking about them is not in terms of levels, but rather stages. Okay, here's the common understanding from the video. Conceptual is, by what most people define it, a high-level, enterprise-wide abstract model. Now, when I say high-level, is there detail under the model? Well, the presumption is that there is. And if I say enterprise-wide, that's simply saying something about the scope. Could I have a conceptual model that was for a department? Could have a conceptual model that was for a multi-line conglomerate organization? Yeah. I pick my scope, and whatever my scope is doesn't influence whether a model is a conceptual model or not. Physical is just the opposite. That's how you actually implement it in storage. Okay? We obviously don't want to deal at that level. And logical, what they typically think of as logical is adding detail to the conceptual model, still free of any physical implementation details which don't contribute to the logical understanding of the model. The logical is often considered to be the ER, the relational model, as it is with Terry Halpin. He considers the relational model to be the logical model. He calls the RM model the conceptual model. That's very confusing because he's using the term in a very different sense than the rest of the industry. And so I would like to find a different term. So it's generally put forth as a pyramid. Move up and you get greater abstraction. Move down, you get greater detail. Now you understand that abstraction is a presentation issue, not a modeling issue. Before we look at those terms, is this a conceptual data model? Based upon what you've seen. The practitioner should really weigh in on this one, right? No, I just want a yes or no on it. Is it a conceptual model? And then I'll say why or why not. Let me tell you that each one of these is a record type that has multiple attributes underneath it. Is this still a conceptual model? Well, it can't be the physical because physical has to be sufficient to implement. And I haven't told you in this model what the attributes are even. So this can't be the basis for implementation. We're missing too much information. I don't think anybody would suggest that this was the physical model, but is it a conceptual model? Is it enterprise-wide? No. Is it detailed? Well, yeah, there's like 41 entities there, but it's still not the full detail. Is it high level? Could be higher, right? Is this a conceptual model? And all I've done, if you observe, that's taken the parcel interest in a parcel of land and said, okay, I'm starting there. Now that includes everything that was in the previous model and then some. Is this an abstraction? Yeah. The extreme. Anybody heard of context diagram in DFDs, in process modeling? This is the zero context diagram, where you put everything in one box. And the very next thing you're going to do as a modeler is you're going to break it out into some pieces. Most people would look at this and say, no, that's not really a conceptual model because there's not enough. The other one wasn't a conceptual model because there's too much. In fact, I have the rule that says A model, and I'm not going to call it conceptual, when you present it to people, should have no more than 7 plus or minus 2 things on the model diagram. Because people can't comprehend more than that at one shot. But that's a presentation issue. Okay, so let's look at the word conceptual. I looked it up in the dictionary. I always go back to the dictionary when I've got some confusion about terms. Conceptual means consisting of, relating to, or concerned with concepts. Abstract is included in the definition of conceptual. Concerned with the definition of relations, of concepts, rather than the facts. Interesting. Synonyms would be theoretical, visual, and imaginary. Antonyms would be real or facts. What's a concept? An idea of what something is or how it works, something formed in the mind, a mental image. But of course, we can't deal with mental images, can we? The only way we can communicate it to somebody else is to get it down on paper. That's casting it in some syntax. If it's mental, how do we document and communicate? If it's entity, object, relationship, identifier, domains, is it already logical? If we add an attribute or a foreign key, is it now relational? I don't think that the use of the term conceptual contributes one iota of understanding of what we're talking about. That's my view. Okay? So what's logical? Of or according, and I love this one, of or according to the rules of logic or formal argument, characterized by or capable of clear, sound reasoning. Synonyms: natural, reasonable, sensible, understandable. Does that sound like something we'd like to produce? Yeah, I think so. The logical data model, a model of some user domain, complete and understandable in the detail needed to represent that domain, built according to and consistent with some formal modeling scheme. The modeling scheme is what contributes the rigor to the definition of the model. The physical data model, how it will be encoded and stored, how it will be implemented in some DBMS, dealing with storage and processing, performance, volumetrics, and things like that, partitioning, distribution. All of these are not questions of what the model is modeling in the user's world. All of this is targeting for storage and implementation. Historically, databases start out as decks of punch cards. And it was hard to look at the punch card and figure out what it was all about. I mean, you wouldn't even know field boundaries, column boundaries. So what we did was we developed the notion of a logical definition or a logical model of what's stored on those physical cards. We wanted to separate that out, leave out the implementation stuff so that we could focus on the important information about the model. And that's gave rise to the notion of a logical representation, stripping away storage considerations. So the physical data model could be considered the stored representation of a logical data model. And we all agree, pretty much, that we don't want to encumber our models, logical models, with anything having to do with implementation. So let me introduce the word abstraction, because it said a conceptual model was an abstract model. The definition of abstraction is simply leaving something out, hiding. We could talk about vertical abstraction and horizontal abstraction. Horizontal abstraction is you got a big picture and you're scoping down to a piece of it. It's a partitioning of it. Whereas the vertical is changing the levels of detail, having more or less detail. There's two times when abstraction becomes an important notion. One is in the process of designing and developing databases, and the other is in the process of presenting a database that's already designed. So in designing and developing, we can't do it all at once, so we have to start somewhere, and oftentimes we can start at a high level conceptual model, recognizing that we are going to eventually flesh it out with all of its detail. The details are presumed to be there and yet to be added. We work on a part at a time. So we can either do it in terms of detail, the horizontal or the vertical. We could also do it bottom up. I read a book one time. It was on personnel data systems. And it was a book that had nothing but hundreds, literally, hundreds of different kinds of data items that would be meaningful in an HR environment. That was bottom-up design. What comes out of a DFD? If you look at the data transfer paths, you say what data is transferred from one process to another. Data flow diagram. It's a process modeling scheme developed by Jordan. But the point out of a DFD is, and that's a useful starting point, is it identifies data items. It's almost like a bottom-up design. And you take all the pieces of data that are floating around in a DFD, and now it becomes the data modeler's responsibility to put together that in a coherent fashion. So I don't care whether it's bottom-up or top-down. Now you've got the full model built, and it's going to have a lot of detail. I mean, the data model underneath that parcel of land with 40-some entities, that document was 400 pages. Now, do you present that to a user all at once and say, here it is, here's your data model. Good luck reading it. We'd be foolish to do that. So, it's already completed. We start with a high-level view, and we successively add detail, and we can do this one part at a time. That's a presentation issue, not a modeling issue. In the dictionary, abstract, the noun, means summary or shortened version. The verb is to take out or remove. I'm also not including the distinction between what we might call an abstract versus concrete. Here are the levels of data models or stages. There is the reality of the user's world. That is infinitely complex, infinite amount of detail. We have to make some choices, right? So we look at it based upon our purposes, we make some choices, we form mental models in our head, but we still can't communicate that until we externalize it, call it a conceptual model, as the industry does. I called it, in my 1986 textbook, I called it the natural unconstrained, or the initial model, independent of any physical storage or implementation. Logical modeling according to some modeling scheme. Question, do you need a modeling scheme to develop a conceptual model? Of course I do. It tells you what you're looking for and how the pieces fit together, how the constructs fit together, and so on, right? That's what the word logical means, interestingly enough. I can't design any model without a modeling scheme. That tells me even how I'm going to document my model at whatever level. So we never have models without a modeling scheme. Physical model defining storage characteristics. Some people distinguish, and I do like to do this, between the physical model and the implementation. I can develop a physical model telling you how things are going to be stored, and then the implementation is how you actually go about doing it in a particular DBMS. The physical model does not have to be DBMS specific. So that's a useful distinction, I think. Data modeling schemes. All data modeling activities is driven by some kind of a scheme. You can think of it as a meta model or as meta-metadata. Tells you what to look for, what constructs to use, how to put them together. This is somewhat repetitive of what you've already learned about. There are rules, logical rules for constructing and putting together your model. It can be developed independently of any implementation. And there are many variants within families. I mean, there is ER modeling, there is relational modeling, there's several variations of that. Since all data modeling is driven by some modeling scheme, i.e. by some logical rules for building a model, all models are logical. Even a physical model is logical. I hope you're beginning to understand that the distinction between conceptual, logical, and physical is not very helpful. Data modeling is not about scoping. That's just setting the boundaries. What do we mean by enterprise-wide? We already talked about that. Simplified. It's not about being simple, high-level, or abstract. Okay? That's a matter of presentation. The syntax chosen to represent the model, that's about the semantics and the meaning of the model. The same semantic can have different notations, and that can be a problem too. I've indicated for manyness. We have the fork, which I propose. We have people use the letter M for many, and I don't know how that fits in Arabic or Chinese. Okay, you might have a different symbol. We want to be internationalized in the notation that we use. An asterisk is used, a double-headed arrow is used for manyness. Physical and storage implementation, performance considerations, that's not part of a data model, I don't think. We want to represent in our data model, our logical data model, only exogenous information to represent the domain. Exogenous information is information which is only obtainable from the outside world. So derived information would be an example of information that is not exogenous. We don't want to introduce any unnecessary artificial or spurious constructs because those are to the path of implementation. And I would argue representing relationships with foreign keys is an implementation question. I would argue even that putting things into table is a step toward implementation in a relational DBMS. Because as you'll see with ORM, I don't put things in the table and I can still get a complete, detailed model. These, to be sure, are all important aspects of data modeling, but they shouldn't be in our first level model. Graham Witt, who is the co-author with Graham Simpson on the book on the essentials of data modeling, probably the best reference on record-based data modeling. Well, I heard him last fall, and he called this the business data model, and I said, that's it. That's what we can call it. It's confusing to call it a data model. We don't want to call it a conceptual model. Everything's a logical model, so that doesn't help to distinguish. But we don't want to call it a business model either, because, I mean, that's really what it is, but it's an aspect of the business domain that we're modeling. We're not modeling the behavior or the processes that take place in that domain. We're modeling the things that exist and are related in that environment. So let's call it a business data model. Back to this. Conceptual is a scoping and presentation issue. I want to throw that out. Physical is not part of the business data model. Logical is what we're left with. And so all data models are logical models. How do we then distinguish them? And this is where I begin to move to the question of let's start talking about when we introduce certain constructs or components into our models. We have to rationalize the differences between these logical models. They may differ based upon which modeling elements are included in the model, i.e. in the modeling scheme. What I proposed to do in the rest of the paper was to lay out the sequence, the precedence ordering of all of the things that have to eventually get done. And there comes a point where you're done with all the detail, and now you're starting to do things that are for implementation. And I would argue that putting things into records and foreign keys and stuff is in that direction. So introducing the design elements, we can put this on a continuum. The one end of the continuum is the mental model. This would be the traditional levels, if you like, of data models. So we go mental model, conceptual model, logical model, physical model, and I add in the implementation model to the stored database, right? You'll see this triangle with 3 levels drawn a lot of different times. That's this classic representation of these levels. Our intersection or associative entities or foreign keys part of the logical model or the physical model. Okay, where does this boundary occur? Let's forget levels and focus on ordering of design elements. That's what I'm doing. And I'm not going to go through the detail of that, but what I'm going to say here is there is the mental model, there's the physical implementation for the database. There's some point in this continuum where we have all of the information that we want and need to accurately model in all its detail the user environment. But before we have introduced anything that's unnecessary or spurious or artificial for aimed toward physical implementation. So up to that point, we say point at which we have all the essential exogenous information, And then beyond that point, that's the vertical blue line, the point from which we begin to introduce additional elements to physically implement the data model. In other words, build the database. What to call it? That's what we propose calling a business data model. And that's not widely accepted at this point. So the modeling constructs, we've got things. We need to worry about names of things, populations of things, the domain of values that represent those things, subtypes and supertypes to model overlapping populations. So there's things, there's relationships among things. And we can be concerned with the characteristics of relationships, the names of roles in relationships, the characteristics of dependency and multiplicity and ternary and beyond. Okay? Then to introduce entity records, clustering clustering attributes based upon relationships and identifiers, foreign keys, keys and foreign keys. I can do a lot of modeling without even talking about identifiers. Because the only time I need identifiers is there has to be some place to point a foreign key in order to represent a relationship. Well, if I just draw an arc between two objects, that's good enough for the users to represent a relationship. I don't have to show a foreign key. The most important thing in data modeling is to have an accurate description or definition of the model's populations. Before we can develop a model, we must first define terms, define our vocabulary from a business perspective in a way that's understood by the users, user domain. In fact, they're the ones that should be doing the defining. Listen to what they say. Listen to how they talk in their domain. Initially, it'll be fuzzy with areas of disagreement requiring discussion and negotiation, and we document that. This is the most difficult and important aspect of data modeling. Call it a business glossary or data dictionary, I don't care, but there's got to be some description of the things in the user world. However, a glossary is usually only for nouns, objects, not relationships. We also need to define the relationships and the constraints. That's at the very front end. This is the last slide that I'll give you, but it is the end of looking at all of these things that we can introduce into our model. So you can see we start up there, we scope, we have user narratives telling us about their world. We come out with fact sentences. From there we identify the verbs and the nouns, and the nouns begin to identify the objects or the entities and the attributes, the verbs, the relationships, and so on. And you'll see this is where we're going. Object role modeling takes us up to here. And here we can talk about identifiers, we can talk about role names. Here we do some clustering to begin to form entity records. And so this is more physical. There are so many arguments that I hear in the field of data modeling that surround the question of identifiers. And if you'd only think beyond the identifiers to think about what is the population of, without getting hung up on how you're going to identify members of the population, it oftentimes will resolve the question of understanding what that model is about. So be careful of falling into the trap of getting all hung up with identifiers. Questions?
So you've effectively thrown out the term logical.
Yeah, because all models are logical.
It applies.
All models are driven by a logical scheme, and that's what seems to me to be the definition of logical.
Okay.
You can't have a model without a scheme,
That makes sense.
a set of rules for putting it together. Therefore, all models are logical models. And so the word logical, see none of those words help us.
And on your slide here, the question mark, do you have a suggestion for what you would put between A and B?
Yeah, that's a good question. No, I don't. You know, the users are concerned with identifiers and the choice of identifiers. You don't need that in the initial stages of modeling. Okay, and that's the point that I'm trying to make here. But early on in the game, before you do any of those other things, you do have to deal with picking the identifiers. Because that's going to be the surrogate in the database. Unfortunately, the choice of identifiers is often poorly done without due consideration for all of the relevant criteria for selecting the identifiers. You may not be convinced yet, but at least I communicate to you where I stand on this question.